All right, today we are going to learn about adding integers. And when we add integers, we need to know a few vocab words. Of course, vocab words would be integers. We need to know additive inverses. And eventually, not for today, but for an upcoming lesson, you are going to need to know absolute value. Integers. The actual definition of integers are whole numbers and their opposites. Whole numbers and their opposites. Now, keeping in mind this is a subset of the real numbers. So when I say whole numbers, what I mean by that, I think of the word whole, and I think of like a mouse hole, and it looks like a circle, also known as zero. So zero is included in whole numbers. Whole numbers are 0, 1, 2, 3, go all the way to infinity. Okay? Their opposites, then the opposite of 1 would be -1. The opposite of 2 would be -2. The opposite of 3 would be -3, and then it goes to negative infinity. That is integers. Okay? Integers are not decimals. They are not fractions. They are whole numbers. Their whole means it's all one. Okay? Additive inverses. They are opposite integers where the sum is equal to 0. Opposite integers where the sum is equal to 0. So additive inverses means they're like opposites. Inverse is another word for opposite, okay? Their sum is equal to 0. That would be like -3 and +3. If you add them together, it's 0. 19 and a -19. Add them together, there's 0. Those are additive inverses. 100 and what would it be its inverse? Class. 100 and -100. 77 and
-77.
-48 and +48. I threw you off there. Absolute value we'll define. We're not going to apply it until later, but it's distance from 0 on a number line. Absolute value is just distance. It is distance from 0 on a number line. You say, how far away? How far away from 0 if I'm looking for absolute value? All right. First extension, we need to write expressions from a number line. When you are given a number line and you have to create a numerical expression, tell me what's going on. The first thing you do is write down where you start. I have to say, okay, where is the beginning point? That is the beginning point. And secondly, I'm going to add to it how much you moved. Notice, add. Put a couple lines under it. That's the most important thing. All right, looking at this first example for a number line and the red line above it, the first thing I need to know is where do I start? Well, it looks like I started right here at -7. So I write that as -7 plus because I know I'm going to add to it. I'm adding something to it. Now, what am I adding to it? I need to figure out how much I moved. I moved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots. So I add 10. What does it equal? Well, it equals wherever I ended up. It equals +3. So I wrote down where I started. I added to it how much I moved. I moved 10 spots. The sum is where I ended up. This is my final point, 3. All right, the next one. we gotta look, where did we start? That's the big box. Where is this example starting from? Brennan?
9.
9. So I started at 9. I started right here. And now I'm gonna add to it how much I am moving. How much did I move? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I moved 10 spots. Did I move 10 positive spots or negative?
Negative.
Negative. So I add a negative 10. And the sum is equal to where I'm at. I am at negative 1. All right, moving on to the next page. We usually follow these integer addition rules instead of using a number line. You are always welcome to use a number line. It just takes longer. You don't want to draw a number line all the time, especially when you have larger numbers. So we have these rules. If they are the same sign, what you do is add them up and make them the original sign. So you add them up and make the original sign. So if they are the same signs, you add them up, keep it that sign. The tricky part is when they're different signs. When they're different signs, you have to take their difference and see which one is furthest from 0. That'll be the sign it is. So take the difference and determine which one is furthest from 0. So 2 rules that you always have to keep in mind. So when I'm doing any kind of integer addition, I'm asking myself, are they the same sign or are they different? And then I follow the rules. Negative 3 plus negative 12, are they the same sign or different? Negative 3 plus negative 12, are they the same sign or different? They are the same. So I go 3 plus 12 is 15. Keep it the original sign. $32 plus a negative 7. Chris, same or different sign? Different sign. So since they're different signs, I need to take their difference, 32 minus 7, which is 25, and then I ask myself, is 32 further from 0 or negative 7? 32 is further from 0, so it will be a positive answer. Whichever one is further from 0 is the sign that the answer will be. Negative 23 plus 18. Cody, same or different?
Same.
Negative 23 plus 18. Different signs. Since they are different, I take their difference, 23 minus 18, which is 5. Now I ask myself, which one is further from 0? Negative 23 or positive 18? The negative is further away, so the answer is going to be negative. .01 plus a negative 1.7. Jasmine, same or different signs?
Different.
Different signs. So I take their difference, lining up decimals, okay, so I have 1.31. Which one is furthest from 0, positive 3.01 or negative 1.7? The positive 3 is further away, so it will remain positive. Okay, that's intense. A rule that is never going to leave you for the rest of your life. In college, you are going to be doing integer operations all the time. They are always there. Fractions. Fractions you should start to love this year. No biggie. Fractions, we got this. They're not a big deal. The first thing you want to common denom. I'm going to say denom because I don't have enough room. Common denom. That's the first thing you're going to want to do. And secondly, I'm going to follow integer rules, not operations, rules. Okay, negative 1/3 plus 3/20. The first thing I want to do is make sure they have a common denominator. So I know that the common denominator is 60. Okay? 20 times 3 is 60, so 3 times 3 is 9. 3 times 20 is 60. Negative 1 times 20 is negative 20. Notice I just kind of put the negative with the top, and that's what I want you to do. Keep the negative no matter if it's on the side, bottom, or anything. Put it on the top. The negative can be anywhere. So now I have this, negative 20 over 60 plus 9 over 60. Okay, Drew, are they the same or different signs? Different, negative 20 and a positive 9. So since they're different, I take their difference, 20 minus 9, 11. So this turns into 11 over 60. And then which one is furthest from 0, negative 20 or positive 9?
Positive 20.
Negative 20 is further away from 0, so this would be negative. Okay? How this one, whoops, I guess that's not it. How this one is set up, the one that I'm moving, how this one is set up is how you will see it on any Google Doc that I create for you to do an assessment. I always rewrite it. I do not like my fractions like this. I like them tall, not slanted. So I'm just rewriting this, negative 4/7 plus a negative 3 over 14. That way I can deal with my denominators much easier. What's the common denominator between 7 and 14, Jasmine?
14.
14 it is. So I don't even have to change this second fraction. I don't have to change it. 7 times 2 is 14. Negative 4 times 2 is a negative 8. So now I have negative 8 over 14 plus a negative 3 over 14. Are they the same or different signs?
Same.
Same signs. So according to my rules, if they're the same sign, I add them up and make it that original sign. So I'm going to add 8 plus 3 is 11, keep it negative, over the denom of 14. Final answer. And that's how we add integers.